liquid oils. Yeah. Good morning, everyone. I hope you are all doing well. Welcome to the International Conference on Pervasive Computational Technologies 2025. My name is Shivan, and I welcome all of you for the AI for Autonomous Systems theme. I am honored to serve as the session organizer for this session. Before we begin, I would like to acknowledge our esteemed session chairs who will be guiding us through today's session. We are honored to have Mr. Nibedan Panda and Dr. Amit Pandit with us. Their expertise and insights will add great value to our discussions. Thank you for being a part of this session. I'd like to warmly welcome all of our session chairs, presenters, and attendees joining us today. Each present will have maximum 10 minutes to present, followed by a brief Q&A session for 5 minutes. A quick reminder to keep your microphones muted when not speaking to minimize background noise. If you experience any technical issues, please use the chat function and our support team will assist you. This session is being recorded, so we appreciate your cooperation. So let's start with the first paper ID. Do we have anyone from paper ID 1184? Do we have anyone from paper ID 429?
Yes, myself, Bhagirath. I'll be going over paper ID 429.
Okay, I'll make you the presenter. You can share your screen now.
Sure, sounds good. All right, can you guys see my screen okay?
Yes, it's visible.
Hello, everyone. Good afternoon, sir. Myself, Bhagirath. I'll be presenting enhancing network resilience with dynamic traffic engineering using load balancing techniques. So I'll go through a brief introduction and current literature review. So the problem statement, the objectives of this analysis or this paper, um, the innovation part, the methodology and analysis, eventually going through the results and discussion, conclude and have present like the future scope of this work. Dynamic traffic engineering with load balancing is the essence of this paper. Enhanced network resilience, DTE combined with load balancing ensures continuous service by dynamically rerouting traffic during failures, reducing downtime, and maintaining service availability. Optimized resource utilization by distributing traffic across multiple paths. The approach prevents congestion and overloading, efficiently utilizing network resources and reducing redundant usage. Improved performance and security, real-time traffic adjustments, minimize delays, packet loss, and vulnerability to attacks by redirecting traffic away from compromised paths. Essentially, what this means is uh, we cannot like quantify or like measure. I mean, we cannot quantify something that we don't measure, and taking in situ actions as opposed to like have set thresholds for coming in from load balancing. So dynamic traffic engineering, I mean, encompasses like qualitatively or quantifying the metrics that measure resiliency and eventually taking actions. So that's kind of the core theme of this work. Um, Again, benefits and future potential: cost savings, prevents over provisioning, and eliminates unnecessary infrastructure costs, upgrades by optimizing traffic flows, support for critical applications, high availability, ensures reliability for time-sensitive services, where uninterrupted connectivity is pretty crucial. As networks grow in complexity, dynamic traffic engineering, along with load balancing, will be essential to achieving robust, resilient, and efficient networks. Some high-level architectures like cluster management and discovery system, as I was talking through, we want to kind of measure, quantify the metrics, and eventually kind of take it through a traffic control system and make the configuration changes. Um, Problem statement at a pretty high level. unclear impact of load balancing and resilience. While load balancing enhances network performance and reduces congestion, its specific role in improving resilience and how to optimize still remains underexplored. Lack of universal resilience metric. The absence of standardized metrics makes it like challenging to evaluate and compare. So we want to kind of measure to kind of qualitatively like take some action. So that's the essence. Most of the current systems are homogeneous, neglect of heterogeneous networks, I mean, nonlinear. I mean, I think most of the failures happen in real world systems because of nonlinearity. Most research focuses on homogeneous networks, overlooking the complexities of the real world heterogeneous networks with diverse devices and things like that. Again, so that's where like measuring and taking in situ actions definitely does help in improving the resilience on some of those IoT systems. And, so evaluating load balancing roles in resilience, investigate and quantify the impact of load balancing on network resilience, develop a universal set of metrics to measure, compare network resilience, design resilience improvement strategies tailored to heterogeneous networks, addressing the unique challenges posed by diverse devices, practical implementation and validation, verify the proposed dynamic traffic engineering and load balancing techniques in real-world networks. All right, so what's kind of um, um, the the ideation or what's different proposed in this paper? As I kind of mentioned, the core theme is in order to kind of act, we want to kind of measure, quantify qualitatively, then make a change. So that's the underlying theme. The proposed model uses real-time network monitoring and dynamic traffic direction to prevent congestion, optimize resource utilization. Algorithms such as shortest path routing, equal cost multi-path routing, and minimum delay load balancing dynamically distribute traffic across multiple paths. So even before like a failure occurs, this is more of, hey, we anticipate a failure. So we, by measuring it, then even before the failure happens, make some changes via a centralized controller um, to kind of optimize for network health and traffic allocation and resource usage, minimizing single points of a failure. System, in the interest of time, I'll probably go through this quickly. Traffic shaping ensures proper bandwidth allocation, prioritizes critical data streams, and prevents network overload, enhancing resilience and real-time performance. Some performance measures. I think the metrics that we used are quality of service. As you can see, the proposed kind of takes out like the number of more inputs. It's still like better on the quality of service. Scalability with the number of inputs goes, I mean, ease of scalability is high, and network throughput, even with like high number of inputs with the proposed method is good with, when compared to some of the other solutions that are proposed. I think bottom line, again, load balancing techniques prevent bottlenecks, reducing delays in data packet delivery and contributing to scalability and resilience. Network availability, traffic prioritization, and dynamic resource allocation methods ensure consistent and reliable service delivery, improving the overall resilience of the network. What are like some of the future steps? Anomaly detection methods, or trying to kind of leverage some of the features in terms of like measuring the network traffic and coming up with like 95% confidence intervals, or like anomaly detection methods wherein, hey, some of these data points are kind of going beyond normal, like more than like 75% quartiles, or like 95%. They're beyond 95% confidence intervals. So that's when like this dynamic traffic engineering um, architecture can come in and dynamically like redirect traffic and things like that to kind of keep the systems resilient. So that's kind of the end of my PowerPoint. Thanks.
Uh, Dear, I have just one query. You were having some five figures. Have you labeled them on the sheet number 11 and sheet number 13? Five. Okay. Actually, they are not visible, so I will not be able to understand what graph you're showing. Anyway, I have just one query. Have you compared your result with any other similar paper or the literature available? Fine, these are the references. But
Sure.
what
So
what
it's compared with like an SDN controller. So that's
which one? Which paper you're talking of? You have
with
compared the result with which paper? See, out of these 10 papers that you are quoting as reference, they're supposed to be the key papers.
the
So out of
correct
these 10 papers,
Tachi M D et al. The model uses algorithm, which is
which
delay in
paper number it
SDN.
is? Which paper number it is?
Okay.
You are referring to
So
a paper, but you're not.
yeah,
Yeah, you're not quoting it in reference.
it's on the paper. I've referenced it on the paper, but it seems like it's missing from this list I'm showing on the slides. So it's very specifically Tachi ML. The model uses algorithm to optimize routing, load balancing,
That
and
is the
delay in SDN.
paper published in
2024.
2024. So about what percentage you feel your proposed method is better than the latest paper in 2024? Because I'm not
Correct.
able to see the graph actually. I'm not able to understand if you can zoom it out.
Mhm.
Mhm.
So you can probably see here around 70% to like a 40% decrease in the quality of service metric, even though like an increased in the number of inputs. So let's say like a 20% reduction in terms of basis point, 20 into 100. So that's about 2000 basis point reduction because of the proposed method.
Mhm. Anyway, thanks. No more queries from my side.
Thank
Uh,
you.
Good afternoon, Bhagirath.
Mhm.
I am Nivedan Panda. I have
Mhm.
some queries.
Sure.
One question that means first question is you have in the slide number 9, maybe in the methodology, you have written there optimize resource utilization. Maybe in the back slide, optimize resource utilization somewhere there, methodology. Proposed maybe work your optimize resource utilization. So my question is, what are the resources and how you are optimizing the resources?
Sure. So, as a simple example can be, in order to kind of say you are working for a banking system, and we want to kind of have zero tolerance for any lag in the data, or zero of tolerance for any latency. So in order to kind of accomplish that, I may want to kind of replicate on um, 3 nodes or 4 nodes to kind of keep as a backup. So that can be like 256 GB RAM with like with the CPU. So that can be like a specific node in order to kind of um, keep that like latency at a higher level, or make sure we're not like the system, so it's not failing over. We kind of have planned to keep 3 nodes. So by employing dynamic traffic engineering, we can definitely reduce down to like 2 nodes,
No,
or
no.
so that's
The
the
dynamic traffic engineering means what? Any optimization algorithm, any optimization process,
Mhm.
specific process I have to follow for the optimization.
Yeah, so that's discussed in detail. So for the optimization, there's like a cost function, which is like a linear combination of all the metrics that are of interest. So in order to kind of optimize resource utilization, or so that's what it means. Like so we kind of minimize the cost function to kind of keep the resources to a bare minimum level. I think the major point to take away here is uh, in order to kind of achieve high resilience and like keep the systems robust, so we redundantly have more compute costs in order to kind of optimize those compute costs or resources, having like a mechanism, or like having like a mechanism to quantify the the health metrics of a system. So, and once it starts to beyond to kind of go certain thresholds, we um, rearrange the traffic via like certain other channels or different paths or so that's kind of the essence of this work.
Be specific. You told one if nonlinearity enhances, then there is a failure. But
Correct.
the real world problem is non-linear. If the
For
real
sure.
world problem is linear, then it's very easy to implement. So
Correct.
realistic problem is non-linear. So how?
Correct.
And if the network is very large or the that means large scale network, then how your dynamic load balancing will uh, deal with that?
Yeah, it is a step better than the load balancing because I mean it's not like this is the end of it. That's when I said like so the next steps would be to kind of employ anomaly detection methods or like leverage. I think the failure rates are pretty less, so we can definitely kind of employ like a classification model to model it out with a synthetic minority over sampling technique because our true failures are pretty low. However, I mean, what I'm trying to kind of get to here is we measure so there's like a certain uh,
Any
um,
particular algorithm you have used? Any technique, particular technique or algorithm can you name?
sure, it's on algorithms such as shortest path routing, equal cost multi-path routing, and minimal delay load balancing dynamically distributed traffic. So those are like the algorithms that have been used.
Okay, so it's okay from my side.
Thank you for your presentation. Next paper ID we have is 583, and the paper title is Computer Aided Diagnosis Multi-Model System Using Late Fusion and Ensemble Learning. You can present your paper now.
I didn't get access to present.
You have the access now.
Yeah, okay. Good morning, everyone. I'm Vanam Nikhil. Today, I will be presenting our computer-aided diagnosis multimodal system using late fusion techniques. In our research, we addressed a critical challenge for early detection of two of the most lethal cancers, lung cancer and brain tumors.
Nikhil, can you
Yeah,
have it in the slideshow? Your PPT in the slideshow mode, so that
yeah. Is it okay?
it's not. It's there. I mean, it is still in the same format. Anyway, continue. You see to it.
Yeah. Today we will be discussing about the introduction and a brief review, problem statement, our objective, methodology and analysis, result and discussion and conclusion and future scope. Mm. Early and accurate diagnosis of a lung cancer and brain tumor is essential because delays or any misdiagnosis can have a severe consequences on the treatment and patient survival. So traditional diagnosis methods rely on either imaging data or clinical information. However, each modality has its own miscritical details. So, therefore, our work is motivated by need to combine these complementary sources to create a more robust, accurate, and reliable CAD system. So, our study's main objective is to drive by three objectives.
Here, your slide is
One is
not moving. We are still on the first slide.
okay. I have changed the slide actually.
Now it's came.
You're not. See, if you could be on slideshow, then it'd be better. Yeah,
I am
please.
on the slideshow.
Okay, here we are having the slides view only. No? Anyway, we move on. But whenever you click this slide, you ensure that you are on the second slide, third slide, so that in case if that is missing, we will be informing you, right?
Yeah, okay.
Bye.
Uh, Now I'm in objective slide. Is it okay?
Yes.
Yeah, it's okay.
Yeah. Our study is to our study is driven by the following objectives. First is to develop the specialized models. We built a separate deep learning models tailored for processing CT images for lung cancer and MRI images for brain tumors, alongside dedicated models for each clinical data. And we have integrated via late fusion. Instead of early merging, we allow each model to operate independently and then combine their predictions at the decision level using late fusion techniques. This way we can assign higher weights to more reliable predictions and improve diagnostic accuracy. By by integrating diverse data sources, our system is designed to overcome limitations of a single modality diagnosis, thus improving overall diagnostic accuracy or reliability. And we employ early detection, where facilities that early identification of lung cancer and brain tumor by overcoming these limitations of a traditional single modality approach. And the methodology we have used is that consists of three main branches, where it consists of three main branches such as imaging branches, clinical data branch, and fusion and decision layer branch. Fusion and decision layer is a core system of our model. In this model, basically, if we take a lung cancer model, a customized designed CNN model is processed through CT images. And here specialized techniques like smooth and weighted class methods are used for data imbalancing. And in brain tumors, we use VGG19 model. These leverages transfer learning from ImageNet, and it fine tunes it and analyze the MRI images. And in clinical data branches, for both lung cancer and brain tumor, both separate random forest classifiers are used for processing them. These models evaluate the key features extracted from the patient symptoms and the histories. And in a fusion and ensembling layer, the core of our system is this model. Here, the independent prediction from imaging and clinical branches are combined at the decision level. We employ a weighted voting mechanism where models with a higher validation accuracy and influence will influence the final decision more strongly. This architecture enables us each data modality to be optimized individually while contributing to overall final prediction, ensuring that the robustness and enhancing the diagnostic accuracy. Our, our evaluation metrics validates the effectiveness of our approach. For example, in a lung cancer detection, the clinical data model achieved approximately 9.98 percentage, and imaging model based on CT images reached around 96 percentage, and brain tumor detection, both MRI based and clinical data, achieved around 97 percentage. And the confusion metrics further illustrate that the late fusion approach minimizes the miscalculation and providing the balanced performance across all classes, precision, recall, F1 score. And by combining multiple prediction, our system consistently delivers high diagnostic reliability. These results demonstrate that integrating multi-model data using late fusion significantly enhances overall system performance compared to single modality approach. In the conclusion, our research shows that multi-model CAD systems integrates the CT and imaging with clinical data using late fusion techniques can greatly improve our diagnostic accuracy for lung cancer and brain tumor. The system's modular architecture allows for individual optimization and robust decision making through weighted ensembling. Moving forward, our future work will be focusing on expanding the data set with a more diverse patient profiles and including additional clinical and image modalities such as PET scans and genomic or proteomic data for deeper understanding of cancer biology and refining the fusion strategy to further improve the accuracy. Yeah, that's it from my side.
Okay, proceed. You can proceed, sir.
No, please, sir, please.
Nikhil,
Yes.
you have taken VGG 19 and some data set you have taken. Maybe which data set you have considered?
For VGG 19 model.
Which data set you have considered?
For VGG 19 model, I have used brain's MRI images.
Brain MRI. From where you have
Yeah.
taken the brain MRI images?
NLST, National Cancer Institute.
Okay.
From their providers. Yeah.
So in that VGG model, how many layers are there?
There are 19 layers.
And activation function. You know what is activation function?
Yeah, I know what is it.
What is
Like
that?
activation function in the sense, in basically in a neural network there are nodes. For a node to get activated, it has to reach a particular threshold. To reach that threshold, activation function is required. For example, ReLU function. It is like there are various. I have used ReLU function in VGG 19 model. It here it because why I have used, because for in case of vanishing gradient, these kind of problems, ReLU function is most compatible with our model. That's why I have used ReLU.
If I am not using activation function, so what is the problem happen?
Node will not get activated, so model will not be trained.
Okay. So activation function is a which type of function?
Sorry.
Activation function is a which type of function? It's coming under which category? Okay, so you have considered VGG and some data set you have considered taken from standard data set. So this
Yes.
is already VGG 19 is already inbuilt model.
Yes.
So it's better if you consider some uh, that is some meta heuristic approaches or some realistic optimization, latest optimization algorithms. It's better so that you can analyze better.
Actually, our main goal is to check whether using late fusion technique we can improve the accuracy or not. Previously, uh,
That is
our
always already proved. That is
yeah,
already known.
Yes.
Sorry to interrupt, but VGG 19 उसमें 19 लेयर्स हैं, वो 1000 ऑब्जेक्ट आइडेंटिफाई कर सकते हैं। और लेट फ्यूजन का फायदा ये है, लेट फ्यूजन में कितने तरीके के, अगर मान लीजिए एक मॉडल फेल हो जाता है लेट्स से लेट फ्यूजन में,
yes.
तो क्या इफेक्ट आएगा आपके हिसाब से?
Then other model, whatever the result will be given, that result will be provided, and note will be given that other model has a failed or some kind other model didn't provide a
Have you
good.
tried? See, what
Yes, I
happens
have
is
tried.
there are
Like
different
we
models,
have
and they are their output is fused as such. यही होता है ना इसमें?
yeah.
Yeah. So what
Actually, while
happens?
fusing, we have used a weighted voting method. For imaging prediction, we have given around
I
0.7%,
agree,
and
but
for clinical data, we have provided around, yeah,
that is already reported in literature.
yeah.
So can you just be specific? What is your contribution, or it's just a review paper?
VGG 19, what is your contribution? Yes.
Yeah,
What is your contribution? What you are doing? You are doing some experimentation.
Yeah,
So
I'm
what
checking
experimentation you
whether
have?
by using this method we can improve the accuracy of these current
that is
models or
already
not.
reported in literature. That is already reported in literature.
Accuracy means that is a simple efficacy measure. Accuracy, error rate, specificity. These are some measures only, efficacy measures only. So have you done some extra thing implemented by your own? manually something implementation, then you have tested the, suppose you have taken some standard data set. On that you have analyzed something. So this is very naive work. This is already there. Okay, this is from my side.
Anyway, I mean, like you are supposed to improve upon, right? This is my kind submission. So VGG 19 is already there. Everything is already there. You run the software, it will give you some output. But we have to understand when you do some research and you present, either it will be a review work, then you are supposed to include many papers, quality papers. And if you are projecting it to be your work, then you are supposed to, I mean, propose something so that either the results get better or they get worse, right? This is
As
a
sir
kind
told,
solution.
this is
Yeah.
something you can start from this. Then
Yes.
you can experiment something else and you can compare. We have compared with VGG and we have seen like this.
Yeah.
Yeah, we have compared and we have improved the accuracy. We have in the
What you
reference
have done to
paper.
improve the accuracy?
Yeah,
What you have done exactly, that is your contribution, and that is what we wish to hear from you.
If you are thinking VGG 19 is your contribution, is it? You are thinking
no,
VGG
not
19.
VGG 19. That basically combining different image modalities into single modality is our main
Is
main
it your
specialty.
UG work or a PG work?
It's a UG work.
UG work, na? So you concern, I mean, connect with your guide and say that I have to develop something so that my results get better and original contribution comes out, right?
Yeah.
That is good for
Yes.
review literature. That is good for understanding the concept, right?
For starting,
That's
it's good.
Yeah, for starting, it's good, beta. Thank you. Best of luck. It's all from my side. I hope, sir, आपकी तरफ से भी over है तो.
Yes, sir. Yes, sir.
Okay.
We'll
Thank you.
go for
Thank you,
the
sir.
next.
Good. We should go for the next. Thank you. Bye.
Thank you for the presentation. Next, we have paper ID 809, Digital Agriculture Platforms. You can start presenting.
Yes, sir. Sir, I am unable to share my screen.
I've given the permission. You can start presenting now.
Yes, sir. 1 minute, just. Is it visible? Hello.
Yeah, it's visible. Can you have it in the full slideshow mode?
Yes, yes, sir.
Yeah, please. Thank you.
Is it, sir, visible?
Yeah, it's there. Please. Carry.
Okay. So, good afternoon to one and all. I am Shruti Patil. I am here to present the paper on digital agriculture platform, empowering farmers and enhancing market accessibility. So, as we know that agriculture is the crucial part of our economy, yet farmers face significant challenges in accessing market, enhancing fair prices for their produce. So, our solution aims to build a digital platform directly that which connect directly farmers to the consumers. This platform includes secure authentication, detailed produce listing, and price negotiation, multi-language support, and so on. So this is our problem statement. The objective of this is to increase farmers' earning by eliminating the middleman. Second, consumers get fresh produce directly from the farm. We empower farmers by providing digital tools such as real-time chat. Also, we provide multi-language support so that everyone can use and should not have any language barrier. This is our methodology, in which we are giving price prediction, that is market trends suggest optimal selling prices for farmers. Then blockchain we have used for fraud detection in payments so that secure payment can be done. Then AI negotiation chatbot, for negotiation between the consumers and farmers for the price. Then also we are having matching prices best based on the demand, price, and location. So our app will show the best location to the consumers from where they can buy the products. And we also have the recommendation system for buyers based on the preference and past purchase history, which will show them the price for selling their goods. This is our result, some of the front end pages which we have included. This is a chatbot which we have given multi-language support. For now, we are using only for 3 languages, that is Hindi, Marathi, and English. But we are aiming in future to use multiple languages in this. So this is a presentation, and for future we are planning to use multi-language support. That is include more and more languages and also increase the area. For now, we are using this only for a specific region. But now we are aiming for full Maharashtra, and beyond that, we are also aiming for full India support. Like we can include multiple languages other than English, Hindi, Marathi, and so on. These are references we have used in a paper. Thank you. This is all from my side.
So in all, what I can conclude is that you have tried to design a web page, right?
Apps actually.
Okay, apps. So app is basically for Android platform or the iOS platform?
So this is for Android now.
Okay. Android, which version?
So for now, latest Android version,
Which is latest? Latest
it's
Android. Which is latest?
Android 15 and so on. So useful for that.
I mean, which minimum Android version this app supports?
But till now we have use it on Android 15 version, so it has worked.
Which simulators you have used?
Sorry, sir.
You must have simulated on some Android simulator, no?
Also, we have directly used this app on the mobile phones. We have even used with some of the farmers' phones as well. So it is working in most of the platforms, and we are not facing any issues
When you
till now.
design an app, you are supposed to write some code.
Yes,
You
sir.
want to have a field of name, phone number, or XYZ. You must have
How you
written
have
some code.
implemented this?
How you have implemented it?
Or
So
no
actually,
implementation is there?
the Android part is one of my team member.
What you have done? What is your contribution then?
So
Let's
my
discuss on
contribution is the front end and ML part all.
ML. What is ML?
So ML we are using for price detection, means if a farmer is want to sell some goods, for that he
Okay.
will be provided a price based on the
Okay.
previous data. Like we have from government data website, we have taken
What is the
past 10
size of
years
that
data.
data? How many instances are there in that data? And which ML
So for
algorithm you
now
have?
we have used 3 algorithms, that is random forest, linear regression, and SVM. From that we have got random forest as the best one. So we are
How
proceeding
many
with it.
instances of data are available? Data का size क्या है?
Well,
कितने instances हैं?
so
100,
उसकी
200,
size
1000?
somewhat around 3000 है. Only for our area, like we have taken Dhulia city,
Okay.
full Dhulia region. So for that we are having
Okay. Out
3000.
of 3000, how many of you have taken for training and how many for testing?
So we have taken the ratio of 70-30.
Why not 60-40?
So we can take that also, but for now we have taken 70-30.
730, 70-30 is a standard, isn't it?
Yes,
So
yes.
somebody might, when they have projected the standard, they must have taken something into consideration.
So like we
And
have built it on 70-30, then we can also include 60-40. We are getting accuracy
yes,
somewhat around
just
now
one
for
clear, just one clear
90.
question to you. One clear question to you.
Yes, yes.
ML you have implemented in which language? Or it was a built-in function that you have called?
In Python language, sir.
Have you created the code or you have just used the inbuilt function?
No, no, sir, we have created.
Created means call the function of random forest SVM like that.
Yes, so we have means build the algorithm and then we have given the data set on it and we got the result. But for the algorithm, we have used Python language.
Okay. The data set attribute, how many attributes are there?
So some attributes are some state, means the place which is there, then the goods names, their past 10 years of prices. This is some attributes, means somewhat around 8 9 attributes in the data set.
Should clearly tell what is the number of that attributes that should be fixed. Like 154, like that you have to tell attribute and instances and attribute. At least this should be minimum fix. And then some models you have used and definitely you have simple call the models not implemented.
So in
Actually, are you
instance
aware of attribute
instances
and instances? The sir is asking one question. Attribute and instances are they same or they different?
different, sir.
Okay. So row wise, what you get, and column wise, what you get in a database.
So row wise, somewhat around 9 to 10, and column wise we are having 3,000. No, column wise we are having 8 to 9, and row wise we are having 3,000.
So which side is attribute and which side is instances?
Column wise is the attribute, and row wise is the instance.
Thank you.
Okay.
This is from my side, sir. आपके पास
Okay. Thank you.
और
Thank
तो
you.
कुछ नहीं? Thank you. Anyone else? Thank you. Can we have the next one, please? Have the next presentation, please.
Uh, Sorry. Thank you for the presentation. Do we have anyone from paper ID 1156? Anyone from 1184? Uh, uh, so let's wait 5 minutes for other authors. We are trying to contact them.
Okay. Hello, पांडा सर
Sir.
कैसे हैं सर? I'm sorry, हमारी पीछे बात नहीं हो पाई. आप कहाँ पे हैं सर अभी?
Hello. Hello. Hello, Amit sir. Hello. Am I audible, Amit sir?
Hello.
Hello.
Hello, Amit sir. Am I audible?
हाँ सर, एक्चुअली मेरे को लगता है मेरा कुछ नेट का इशू हुआ, मैं फिर से रिकनेक्ट हुआ इस बीच
Okay.
में. मैंने
Okay.
आपसे क्वेरी किया, मतलब बात करा और उसका एकदम से मैं वापस चला गया, डिस्कनेक्ट.
Okay, sir. I am working as associate professor in Kalinga Institute of Technology,
ओके.
KIT
किड्स
University, Bhubaneswar, Odisha.
भुवनेश्वर. That's a nice place. I've
Sir,
been to
now you are
Bhubaneswar many a times, to SOS, SOA.
SOE. Yes, I have worked 10 years in SOE.
Okay, which department?
Become CSIT.
ESIT.
You are from which
Uh,
university?
So I'm professor in Mata Vaishno Devi University, Katra.
Katra. Okay, okay, okay. Katra. One of my teacher just now joined as assistant professor in their Central University. Something. I am Katra is there, na?
I am
I am. I
Jammu.
am Jammu. I am Jammu.
I
Yes,
am
yes.
Jammu. Yeah.
I am Jammu. He has joined recently.
Okay. In management?
No, no, no. Computer science.
IIM or IIM IIT Jammu?
No, IIM Jammu, computer
Oh,
science assistant professor.
okay. Have you ever been to this Katra, Jammu Kashmir की तरफ आए हैं
Yes,
आप?
I am interested. I will go definitely.
Yeah,
Uh,
please do
uh,
come. Please do.
so,
Professor Mohanty is there in SOA, electronics
net,
department. He does the conferences and all,
yes, that is, yeah, I know. Manti electronics.
electronics. Yeah.
Hmm, hmm,
So
hmm.
we are good friends.
Hmm, hmm,
He
hmm, hmm, hmm.
generally his PhD thesis and all.
Hmm,
He
hmm,
used
hmm,
to.
hmm, hmm.
So whenever you
Nice,
plan,
sir.
do come. You have my email ID now, and we can
Definitely,
make
sir.
a start. Hmm?
I'll definitely contact in the email idea. And my PhD students are now one in horse, so background will talk, sir, regarding that.
Right. Okay.
Thesis related things.
Right. We definitely do that. Any participant now? Any participant?
Good
Paper
afternoon,
ID
sir.
1224. Yeah.
Yes, sir. Paper ID
You can start
1224.
you can start the presentation if you're ready with
Okay,
that.
okay, sir. Sir, can't be able to share the presentation.
Okay, just hold on. The coordinator will allow you.
I've given the rights to present.
Okay. Ashna Goyal. Your paper is in this session or other one?
Sir, actually, it was in the previous session. That starts at 11:30. But
Okay.
I am in hospital. My father has been admitted last night.
Oh,
That is
sorry,
why I
sorry to
can't
hear.
be able to join at that time.
Right.
When I joined
No,
at
no,
12, the session was already over. So
no
they
issue,
have.
no issue. How
Uh,
is he?
It is better. He is better now. But we still I am in
Okay.
hospital, and from there
No, don't
only I
worry.
am giving this
You please
presentation.
start. You please start. Don't worry. As soon as possible, you immediately come to the result and conclusion part so that you can take care of your father first. Right?
Okay, sir. Okay, sir.
Okay. Thank you.
So here I am Archana Goel presenting the paper on automated food disease diagnosis leveraging machine learning techniques. Uh, these are my table of content, introduction, the problem statement, objective, and all. Agriculture plays an important role in global food security and economic stability, and it is very important to identify the diseases occurring in the this fruits and agricultural products, so that the wastage will be less as for the farmers, and they have less economic uh, uh, my paper is basically on identifying the diseases in the previous stages, so that the yield of crop could be increased, and the quality of the uh, this the agri- this basic the fruits will be increased. The proposed fruit this system detection uses the image processing and machine learning techniques to identify and classify the disease affecting various fruit crops. In this, I have used some feature extraction techniques, in which we have used the statistical methods like mean standard deviation, discrete wavelength transform, and discrete cosine transform to extract the meaningful patterns from the images available. We have implement integrate in this system. We have integrated multiple machine learning algorithms like KNN decision trees, CNN, ANN, and a hybrid approach. Propose a hybrid approach for CNN and ANN to detect the diseases and uh, make the disease predictions. My problem statement is, as we know, fruit cultivation plays a very vital role in global agriculture and food security. It is very important to say this impact the fruit quality and yields to basically reduce the economic losses for farmers. जो traditional disease detection methods, they are time consuming. They have manual inspections, labor intensive, and they produce inaccurate results in detecting the diseases. But with the advancement in machine learning and other new technologies and computer vision, the automated disease detection prediction has become a promising solution. Basically, the challenge is to develop a robust and efficient system that can accurately classify and predict the fruit diseases. So we have uses that image processing and deep learning techniques for detection of fruit diseases. My objectives are to implement a robust image processing pipeline that enhances image quality through resizing, grayscale, conversation, and noise reduction. I has utilized both statistical and various advanced feature extraction methods like statistical methods like mean and standard deviation, and extraction methods like DWT and DCT to improve the disease detection accuracy. And the third objective is to evaluate and compare various machine learning classifiers like KNN decision tree, CNN, and ANN, and the hybrid CNN plus ANN model to achieve the optimal classification performance. The methodology is this proposed fruit detection system is designed as a comprehensive solution for advancing the image processing and machine learning techniques. We have taken a fruit disease image data set in various formats, undergoes a pre-processing step, decrypting and enhancing the images through resizing and conversion to grayscales. Uh, two different two distinct methodologies are proposed for feature extraction and classification. The methodology incorporates the standard measures like mean and standard deviation, and coupled with the advanced methods such as discrete wavelength or DWT and DCT. Classification is achieved through a diverse set of machine learning algorithm like KNN, decision trees, combination, CNN, and AN, and hybrid CNN plus ANN approach. This is my methodology and analysis. These are the various steps which are produced in our methodology. We have taken a data set and pre-process it using image resize and grayscale conversion. After that, using these, we have extracted the features using the various methods like mean and standard deviation, DWT and DCT. Then we have splitted the images. We have test and train the images and they classify them into different types. Uses the ML and DL and other techniques to classification and uh, uh, get the results and analyze the results for accuracy, precision, recall, and F1 store. So this is the basically the flowchart of our methodology. These are our results, and in which we have resized the image and get the having the grayscale images of a data set. Uh, these are the grayscale images, and these are the various results on the basis of various techniques like decision tree, KNN, ANN, CNN, and these are the results of our proposed hybrid algorithm. For Apple,
The slide is
in
not moving. If you can,
yes,
you
sir.
are on the result, na? If
Yeah,
you are on the result page, na? I mean, the slide is
yeah,
not
yeah.
moving.
Slide is not moving.
Yeah, please go to that slide number. You click it
So
out there.
I am on the results and discussion slide only.
What we see is methodology and analysis only.
Yes.
Okay, I'll try. Uh, is it
Please, you
shown,
click on
sir?
that slide.
Now,
You, no, you click on that slide
so I
in the
am
left
clicking.
pane. In the left pane, you are
I am
saving.
clicking, sir. I am clicking.
Okay.
I am clicking, but is it seen on your screen? No.
No, no.
If do one
Okay,
thing,
I'll
no, no, you do
reshare
one thing.
again.
Left side, you have a format background. Close it.
Sir, I am actually full screen over here. So I will reshare
Yes,
the
screen. Yeah,
reshare
please.
uh, reshare the screen. Now is it visible to you, sir?
Yes, results and discussion.
I kindly request On the right hand side, you are having a link open format background. Close it.
Sir, I am not viewing any actually.
Okay, कोई बात नहीं. You continue. If you can go in the slideshow mode, F5. If you can press F5. You go to slideshow. You go to slideshow.
Slideshow. The slide is in slideshow mode, sir.
No, no. Anyway, continue, please.
Okay.
Continue, please.
Now is it shown, sir?
No.
No. How is it possible? Okay. Now is it showing, sir?
Yes,
Yeah,
result and
please continue.
discussion.
Yeah, result and discussion. You can continue.
Okay, sir. So these are the results for proposed hybrid algorithm. As you can see, the decision tree on true apple gives us 94.2% accuracy, but in our proposed hybrid, it is giving 96.85. And for other fruits are also the accuracy have been increased in some or more proportion. This is the specificity performance of all fruit diseases using our proposed hybrid algorithm. We are trying to increase it, and as you show for apple, avocado, guava, strawberry, and other fruits, it is 96 or 96 or around 96.96 and between 96 and 97. But in other systems like decision tree and KNN, ANN, it is between 94 to 95 percent accuracy. This is the sensitivity performance for all fruit diseases. Uh, uh, shall I continue with the next slide or?
Yeah, please
No.
continue.
This is the EBSCO performance of all fruit diseases. As you can see, the performance is also increased in this results also. This is the conclusion. The proposed hybrid CNN and ANN model demonstrate a more robust and effective approach for image classification. And basically, in the context of fruit disease detections, the combining by the strengths of CNN for feature extraction and ANN for classification, the model is able to effectively capture the both level and high level patterns with the data. CNN component excels at great learning spatial hierarchies from images, while the NN parts enhances the model ability to make accurate precision predictions based on these extracted features. The result is basically obtained through this hybrid approach, which indicates a significant improvement in the classification, accuracy, sensitivity, and specificity as compared to the traditional approaches. The hybrid model allows us for potential adaptation to other image classification challenges also. Uh, and these are the references.
Can I ask some questions, madam?
Yeah, please, sir.
Hello.
Hello.
Yes. Am I audible?
Yes, sir.
In last slide or something in the methodology slide, madam, you have shown in the slide number 7. Please, can you go to the slide number 7? Slide number
This one.
7. Slide number
This,
7. Methodology and analysis.
this one is the methodology and analysis slide, sir.
Now result and discussion is showing. Okay, so it's
Okay,
not
okay,
visible.
okay. I'll
Okay, slide number 7. So in the slide number 7, madam,
in this.
you have incorporated KNN, dysentery,
Yeah,
CNN, ANN.
जी sir.
So ANN. So that means what you understand about the ANN. So MLP is ANN or not? Multi-layer
Uh,
perceptron or
जी,
functional
yes
link
sir.
artificial neural network FLAN, FLANN, FLAN, or PSNN, Pi Sigma Neural Network, or WNN, Wavelet Neural Network. These are all are coming under ANN or not? So then which type of ANN you are incorporating? My first thing. Second thing is ANN is suitable for which type of data? Numerical data. And CNN is for new image. So what is the benefit of integrating both? And another thing, ANN, whenever you are talking about ANN, please specify which ANN, artificial neural network, which ANN, MLP or FLAN or PSNN, Pi Sigma neural network, wavelength neural network. These are all types of ANN. So you can continue. For which type of ANN you have used and why you have integrated CNN, ANN? What is the advantage? Why we are integrating this? And if you are talking about a hybrid model, CNN, ANN, these are all are networks. We are going to optimize these networks by using some optimization tool, technique, or a model or a algorithm approach. So, what is the benefit of making CNN plus NN, or simply to make it? Is it have some significance? You can go for answer. My question is clear. Am I audible?
Hello,
Am I audible?
hello,
Hello.
मैम
hello.
सर का जो क्वेश्चन था वो आपको समझ में आ गया है?
सर एक्चुअली आपकी आवाज नहीं आ रही थी तो मेरे को लगा शायद अभी आप रुके हुए हैं. कैन यू रिपीट द क्वेश्चन?
सर
ANN.
हाँ प्लीज.
Yes, sir. Please, sir. Continue, sir.
आप करें सर, मैं आप ही के क्वेश्चन को कर रहा था. आप करें.
Madam, you have used ANN.
Yeah.
ANN, artificial neural network. So many types of artificial neural networks are there. Which artificial neural network you have used? Or that is a simple, you have called the function of ANN? First question. Second question is why I am integrating ANN with CNN? ANN is a network, CNN is a network. So that is suitable for some different thing. CNN is suitable for different thing. We are going to optimize the, if that means the parameter hyperparameters of CNN or some parameters of ANN. If we are going to optimize, then we are going to get a better result. Then why? What is the benefit of integrating CNN and ANN?
Sir, basically, we have optimized the result. We have predicting the accuracy and this other parameters like performance, F1 score and all. तो वी आर ऑप्टिमाइजिंग द रिजल्ट्स. जो प्रीवियस रिजल्ट्स हैं हम उनकी और एक्यूरेसी को इंक्रीज करना चाहते हैं सो दैट वी कैन दिस डिटेक्ट द डिसीजेज इन अर्ली स्टेजेस. जितनी एक्यूरेसी बेटर होगी इनको डिटेक्ट करने के लिए उतना ही थोड़ा previously the farmer will be able to identify the diseases. So to basically to optimize the previous results to increase the accuracy, we have used these models.
Madam, what is the fast input to the model? What is the
So
fast input?
fast input.
What is the fast input to the model? Suppose I am giving fast input something because you are integrated CNN and NN. What is the, maybe there is some benefit. I can't understand why you are integrating these two, because its functionality is something different. That is functionality is something different. If you are talking about some hybrid model, then some optimization algorithms we require and some so many operators are there we are going to hybridize. Why? Is there any benefit of hybridizing CNN and ANN? My one question. And second question is, which ANN you have used? And some efficacy measures you are getting, it's fine. That is accuracy, sensitivity, and some accuracy measure. If the accuracy is better than previous one, it's fine. That accurate. Why you have made this? Is there any significance to make CNN plus AN as an integration? Okay, sir, you can proceed.
Sir, no more question from my side. Sir has put a question called fast input to an ANN. What exactly it means? Am I audible?
Yeah, sir. Yeah, you are
Anyway,
audible.
no problem with that. You carry on. Take care of your father.
Oh,
Right. Thank you.
okay, sir.
Good day.
Thank you. Thank you.
Thank you,
Thanks.
sir.
Okay, thank you,
Continue
ma'am.
with the next participation.
Stop your
Can I
presentation.
leave?
Yeah, you can stop your presentation.
Okay, sir.
कोई नहीं है।
May I leave the meeting also?
Please feel free to leave.
Yeah, ma'am,
Thank
you
you,
can.
sir. Thank you, sir.
मुझे लगता है सर कोई है
Yes, sir. There are no participant
no
here
participants
for
now.
presentation.
So actually सर जो क्वालिटी ऑफ जो वर्क है ना वो कहीं ना कहीं गिरता जा रहा है.
Yes, sir.
पेपर ऑन नमस्कार सर. जय माता दी.
नमस्कार सर.
एक्चुअली मुझे लगता है सर कई बार क्या है ना पेपर हम लिख तो रहे हैं तो क्वांटिटी तो हो रही है बट जो लोग हैं ना वो कहीं ना कहीं बेसिक कॉन्सेप्ट भी नहीं कर रहे. और आजकल सिमुलेशन में क्या है यू पुट अ गार्बेज एंड यू गेट अ गार्बेज आउट एंड यू एनालाइज द रिजल्ट एज पर योर कन्वीनियंस.
Yes, sir.
मेरे को लगता है इसमें थोड़ा सा जो गाइड का रोल है ना वो ज़्यादा इंपॉर्टेंट हो जाता है. कई बार गाइड भी देखता नहीं है कि बच्चे ने कोई रिजल्ट निकाल दिया एंड देन मूव ऑन गोइंग. और थोड़ा सा रिव्यू प्रोसेस को भी हमें स्ट्रिक्ट करने की ज़रूरत है. पीपल आर नॉट अवेयर ऑफ व्हाट दे आर डूइंग एक्चुअली व्हाट दे आर प्रेजेंटिंग. बट आज की इसमें बजवर्ड है ना जैसे AN CNN ANN ML डीप लर्निंग. सो यू यूज दोज वर्क नैनो सेल एनीथिंग लाइक दैट.
Sir, that
Right,
means, sir,
sir.
CNN
Right, sir.
different used for different purpose. ANN different purpose. Which ANN also, sir, they are unable to tell.
आपने पूछा ना फास्ट इनपुट दे रहे हैं तो कैसे ऑप्टिमाइज किया होगा इनपुट को. वो एक्चुअली कॉमन क्वेश्चंस है. पर हो क्या रहा है जैसे आपने देखा ना वो ऐप जो बच्चा बता रहा था ऐप बनाने के लिए यू डोंट नीड एनी एक्सपर्टाइज नाउअडेज.
Yes.
है ना. छोटा मोटा ऐप कभी भी आप बना सकते हैं अनलेस एंड अनटिल यू आर ट्राइंग टू हैव सम कॉम्प्लेक्सिटी इन दैट. बट एनीवे इट्स गुड थिंग. यंग माइंड्स हैं तो उनको प्लेटफॉर्म तो मिलना ही चाहिए. एनीवे थैंक्स टू द कोऑर्डिनेटर्स
If
आल्सो.
they are BTech students, is good, sir. But if they are PhD students or MTech students, not
No,
at all good,
sir,
very
I'm sorry
bad,
to
sir.
say, but nowadays the UG students have taken over the quality comparable to the PG students.
Yes, they are doing the
Yes,
better work, sir.
and क्योंकि मैं आपको ऐसे देख रहा हूँ कि हमारे यहाँ से जो स्टूडेंट फॉरेन में जा रहे हैं MS करने, so they need quality papers and quality work to showcase if they are looking forward to some grants, scholarships and all. तो मैंने देखा है कि they are definitely doing good works.
Sir, under my supervision now, one BTech student is continuing. Currently, he is in a sixth semester. Now already, sir, 7 papers done over out of 4 SCI.
That's wonderful. No? So that fellow will be landing somewhere in a good institution for MS and other things.
No, that is
right?
a BTech student. That's what I'm telling.
That
Sir,
is the
they are
BTech
doing
student. That's what I'm saying.
the
For MTech or PhD, he will be landing in a better institution.
better, yes.
Yes.
So best of luck for him. And thanks to all the coordinators for giving the chance to be present in this gathering. Thank you.
Thank you, sir. Thank you for your
Thank you,
valuable
sir.
insight.
You have Vishwajit Pandey ji now there.
No, sir. This side Dr. Saurabh Sangwan and this is Mr. Sandeep.
There's one professor Vishwajit Pandey who has just joined.
Recently.
Vishwajit Pandey. Anyway, no problem.
Yeah, we are comparatively new, sir. We are not.
Okay. Okay. Thank you.
Okay,
Bye-bye.
thank you. Thank you
sir.
for
Thank
your
you, sir.
insights,
Whenever
sir.
you plan
Thank you
to
very
come,
much.
come up. Yeah, whenever you plan to come to Katra, Vaishno Devi, be my guest. Just
Sir,
inform me.
share your
हाँ,
mail ID and mobile number. Sir, whenever you come to SOA, definitely you call me.
एक सेकेंड मैं चैट में अपना फोन नंबर लिखता हूँ. You can send the hi.
Yes, sir. Yes, sir.
So I hope mobile will be a better option. Is it
Yes,
there?
yes, yes.
Yes.
ये मेरा मोबाइल नंबर है. So whenever you, I'm Amit Pandit, electronics department. So whenever you plan to come, be my guest. Right?
97977 95834.
9797795834. Right, sir? Bye-bye.
Yes, sir. Yes, sir. Thank you.
Thank you.
Bye bye, sir. Thank you. Thank you very
Thank
much,
you.
sir.
Thank you, sir.
Thank you.
Yes, sir.